So it takes 360 degrees to go around the outside of a circle, but it also takes 2 pi radiuses to go that same distance, right? So what we could say then, because we're talking about the same thing here, 2 pi radiuses, it goes around the circle in the same way that 360 degrees goes around the outside of the circle, we can kind of say these two things are equivalent. 360 degrees is equal to 2 pi. We're not going to use the word radiuses or radii. We're going to use the word radians. Okay. And so radians, right, is a concept that you've heard before, probably maybe starting in geometry, but also in algebra 2, right? And so it's a scary and confusing thing that we have to talk about sine and cosine and tangent, and everyone's like, oh, timed quizzes, and it's like bad nightmare kind of memories and stuff. So yes, right, these are the same radians. Okay, these are the same radians, right? But there's a different way to think about like how they're derived. And maybe you already figured it, you already talked about this before, and you forgot or whatever. But anyway, so this is where it comes from. Okay, radians are merely a different unit of measure for angles. Just like we measure length with both centimeter and inches, right? And 1 centimeter is not the same measure as 1 inch, but we can convert between the two, and they both measure the same thing. Degrees measures the exact same thing as a radian does, just in a different unit, right? So degrees, 360 degrees, versus 2 pi radians are the same thing. And so with that being the case, then we know some other measures as well. So for example, if 360 degrees is equal to 2 pi radians, what would 180 degrees be equal to? How many radians? Pi radians. How did you get that, Cole? Okay, you just remembered it? All right. Well, let's just look here mathematically. To get from 360 to 180, what do? It's divide by 2, or half of it, right? What's half of 2 pi? Pi. Same idea there. And we can keep going, right? So I could have it again. Half of 180 is 90, so that'd be how many radians? 1/2 pi radians, or we would normally say pi over 2. Okay, or pi over 2 radians, right? And we could keep going. We could say, okay, what about 45 degrees? Well, that'd be pi over 4, right? Half of pi over 2 is pi over 4 radians. Okay. So there are some kind of common degree measures, and they're equivalent common then radian measures as well. All right. And so this is we're not going to get into unit circle stuff today. We're going to be getting into tomorrow and then the following days and stuff like that. Okay. We're not getting into them today, so don't fret. Okay. This is not all right, now what's sine of pi over 3? No, we're not going to do that today. That's saved for another day. All right. Let's see here. So then we can come up with a way, because then what about if I had something like this? What about 20 degrees? How many radians does that equal? And actually, you could come up with that, I guess, pretty easily from this. Can anyone come up with that right now? What is 20 degrees in terms of radians? How many radians is that? It is possible there. Can I figure out? Julie?
Is it pi over 9?
Pi over 9, that's right. How'd you get that?
Divided 180 by 20.
Yeah, so 180, okay, divided by 9 gives you the 20 there, exactly right. And so then pi divided by 9 will give you the number of radians. And so it's pi over 9 radians. Okay, pi over 9. But what about again? So we want to be able to convert back and forth between from degrees to radians and radians to degrees. That's why I'm putting the arrows in both directions. Okay, so how are we going to do that? Well, let's say again we want to convert, and now I'll make it harder. Let's say I want to convert 21 degrees to radians. Okay. Well, we can use a ratio, okay, or really a proportion, all right? And it's kind of up to you, whichever proportion you want, whichever ratio you want to use here. I would suggest using the 180, and that matches up with pi radians, so 180 degrees over pi radians. Okay. So use that conversion, 180 for every pi radians, will then equal, and then my ratio over here, to complete this proportion, well, what number am I going to put here on top? If I'm trying to convert 21 degrees to radians, what number is going to go up on top here? 21, because I want to convert 21, which is a measure in degree, to x, whatever that x value is, radians. Okay, so we're just setting up a proportion here. That's all it is. To convert from degrees to radians, or vice versa, from radians to degrees, all you got to do is set up a proportion. Start with a known degree in radian measure, so we know that 180 matches to pi. And I like, this one's a good one. It's as simple as it gets. Right, you could use 360 over 2 pi if you want to, because those match up as well, but 360 over 2 pi, that simplifies to 180 over pi. So again, I'd suggest just using the 180 over pi. All right. But we can cross multiply here, so we get 180x equals 21 pi. Okay. Divide both sides by 180. We get 21 pi over 180. Which we can leave it this way. If we wanted to, we could like divide it all out and say that's, you know, approximately 0.367. I guess I'd round that up to. Okay. You know, if I did 21 times pi and then divide by 180, I could get that. But, you know, it's debatable. I think it's not as nice to work with because it's like an irrational number. So I say leave the pi out. Okay. This is a better answer, I would say, than this. But 21 over 180, we can simplify that, can't we? What does that simplify to? Or what can we divide out of both 21 and 180? A 3, right? And so we could really call that 7 pi over 60. And then that's as simple as it gets. Okay, so you do want to simplify. You do want to simplify. Okay. But there it is. Okay. We can also convert 5 pi over 6 radians to degrees. Okay, you can also convert that 5 pi over 6 radians into degrees. So, like, here's another example. So in this case, again, I'll start with the 180 over pi. Okay, kind of my known ratio there, 180 degrees always matches up with pi radians. They're the same thing. And in this case, that 5 pi over 6, where does it have to go? Where do I place that? Since that's now a radian measure, where should that go to match up? Does it go in the numerator up here? Does it go in the denominator down here? Into the denominator, right? Okay, denominator, because it's a radian measure, right? 180 degrees over pi radian means I need my radian measure to go into the denominator here. And yes, we're going to have a fraction within a fraction. It's okay, we'll take care of it in just a sec. And then we'll say that's equal to x degrees. We don't know the number of degrees it's equal to. So now we cross multiply here. 5 pi over 6 times 180, pi times x. So you get pi x equals, and then, okay, 5 pi over 6 times 180. Okay. Well, before I multiply these, I can simplify the 180 and the 6 there. 180 divided by 6 is 30, and that makes that just a 1. So it's 5 times 30, which is 150 pi, equals pi x. Okay. So you can simplify some before you multiply. And then we can divide both sides by pi, and so x is 150 degrees. Okay, 150 degrees. So why don't you guys try Okay, I'm going to give you two. Convert .300 degrees to radians. And then, so that's the first one. And then convert some number of degrees, or what number of degrees gives you 7 pi over 6 radians? Okay. So answer those two. First one, 300 degrees gives you how many radians? And the second one, how many degrees gives you 7 pi over 6 radians? Okay. So set up a proportion, right? So let's say radian degree measure that we know go together. Sure, but I suggest let's use 180 over pi. That'll make it a little easier. So let's say 180 over pi equals now. That was degree over radian. And here you're converting degrees into radians, right? So in the ratio over here, what should go on top? Close. It's degrees on top. So what should go over here? 300 over that. It's even in terms of top. Okay. Just simplify. That's good. Yeah. So what I would suggest, leave the pi out. In other words, just take that 300 over 180 and then simplify that fraction. So leave the pi over 3, put the pi back in. You can use the decimal, that's fine. That'll be useful in some applications, but for the most part, we would leave the pi out. What? Sorry. All right, so we should have gotten 5 pi over 3 and 210 degrees there, okay? Any questions on those two? I have a little bit more, and then we're done, okay? So we should have about 20 minutes to work on your homework here, hopefully. So we're not quite done yet. Just soon. No questions on converting, though? We're all good on that? Okay. So then, one other thing I wanted to talk about, too. If I can find it. Bless you. Okay. And this is related to the warm-up that we talked about today, too. I want to talk about coterminal angles as well. This is another thing we kind of throw in as an introduction kind of thing. Okay. So, coterminal, right? Co, prefix meaning to share, right? Cooperate, share the work, right? Okay. And then terminal meaning to like end, right? Or start, I guess, in some places, right? When you go to an airport, right? And you're like, you go to the airport terminal to either start or end your flight. That's where you both start and end, I guess, your flight. Okay. So sharing the same starting point and ending point. That's what a coterminal angle means, okay? Angles that share both the same start and the same end. And that's basically what we were calculating today in the warm-up. Angles that share the same starting and ending positions. Okay, and if we recall, right, Devin, do you want to say what was your secret again to figuring out the different coterminal angles when we were talking about degrees? What did you do? You added 360 degrees to the original angle. That's right, because you add 360 to something that's essentially like adding 0 because it doesn't go anywhere, right? 360, it just kicks you right back to where you were. So, 4 degrees, all you need to do is add or subtract 360. We can also talk about going negative 360 degrees too. Remember, that's just going the other direction. Okay? So when we had that, we had that 30-degree angle here. Okay? We could talk about going 360 plus that 30. So we could talk about going kind of, like one full rotation around 360 plus that 30 would then be really 390 degrees. Okay, so 390 is coterminal to that 30 degrees. Okay. But alternatively, we could subtract. We could do 30 degrees, take away 360. So 30 minus 360 would take us the other direction because we're going to have a negative angle. Okay, so 30 minus 360 would take us around this way to right there. 30 minus 360 is negative 330 degrees. Okay, so 30 minus 360. But they both get us in the same position. They're coterminal, and in fact, you come up with an infinite number of things, right? I can keep adding 360, so I can do 390 plus 360, and then that plus 360, and then that plus 360. I can get an infinite number of coterminal angles, and the same thing in the opposite direction. I could keep subtracting 360 minus 360 minus 360 minus 360 minus 360, and get an infinite number of coterminal angles that would all end up in the same position. So 390 and negative 330 are coterminal to 30 degrees. They share, the same starting and stopping point, terminal. Okay. So, all right, that's pretty easy for degrees. What about for radians then? Well, what do you think? What can we do to find coterminal angles in terms of radians? What should we do, Kevin? 2 pi radians. Yeah, very good. Yeah, add or subtract 2 pi radians because 360 is the same measure as 2 pi radians. So just add or subtract 2 pi. Okay, the math is a little bit trickier, right? It's a little bit trickier. So for example, if I have 7 pi over 6, okay, and I want to add 2 pi to that, we could use our calculators, we could get a decimal here, but let's not, right? How can we add these two things? What do we need? Common denominator, right? And so it's going to be 6. So 2 pi in terms of 6 is how many 6? 12. So 12 pi over 6. So add those two together and you get 19 pi over 6. Okay, so that is coterminal. The 7 pi over 6 there. And likewise, we can subtract 12 pi over 6, or 2 pi in other words. Subtract 12 pi over 6, subtract 12 pi over 6. Keep adding 12 pi over 6 plus 12 pi over 6. I mean, we could find an infinite number of these, right? We keep going, so it'd be like, what, 31 pi over 6 would also be. 43 pi over 6 would also be coterminal. 55 pi over 6 would also be coterminal. You just keep adding that 12 pi, and they're all going to be coterminal. 12 pi over 6, and they're all going to be coterminal back to that 7 pi over 6. They're equivalent, same position. Same position. Okay? Questions on any of that? We're all good there? All right, so then your assignment is as follows. Okay. Page 288, and it's like a smattering of problems here. 17, 27, 41, 50, 57, 60, 62, 69, 74, 79. Okay. Question?